a block on an inclined plane moving down the plane because of an applied force. Now, in this case, we're going to go ahead and make the applied force in the upward direction. So we'll put force applied here. Gravity is acting straight down. We're going to call that the force of gravity. Here we have the perpendicular force. And here we have the parallel force. That's 90 degrees. And this is the angle theta. This is the normal force. We'll put the vector signs above the forces. All right, that's almost labeled. Here is the force of friction. All right, sine theta is equal to opposite over hypotenuse. So sine theta is equal to F parallel over FG. So F parallel is equal to FG sine theta, which is mg sine theta. FG is equal to mg. Cosine theta is equal to F perpendicular over FG. F perpendicular is equal to Fg cosine theta, which equals mass times gravity times cosine of theta. Now let's look at our forces. The sum of the forces along the x direction would be equal to, it's being pulled up. Let's say the applied force is actually enough to pull the object up. So it's going in the upward direction. So we start with force applied. Force applied minus force of friction minus the parallel force. So the force applied is pulling upwards. The parallel force is downwards. The force of friction is downwards. Since they oppose the motion, you subtract. That's equal to mass times acceleration. Force applied minus. The force of friction is mu mg cosine theta from earlier. The parallel force is mg sine theta, and that's equal to ma. And this leaves us with the force applied being equal to ma plus mu mg cosine theta plus mg sine theta. You can factor out mass if you want and have that off to the side, or you can just leave it as it is. A couple things you could look at. If acceleration is equal to 0 and velocity is constant, that term goes away. So you would be left with force applied being equal to this and this. If there is an acceleration, you would leave it in. And we don't really have to solve for the y direction between F normal and F perpendicular because the object isn't moving either up or into the incline. So this is all we really need to solve for. Now, we could solve for force applied or acceleration or the coefficient mu, theta, or mass. Let's just show you how you would manipulate this to solve for acceleration. Force applied minus mu mg cosine theta minus mg sine theta divided by mass is equal to acceleration. And I'm showing this again because from the last video, you can't divide out the masses even though they're in these terms because there's not a mass in the force term. So if it's not in every single term, you can't divide it out. You have to leave it as is and just plug in your numbers.